New chapter, chapter 2, lesson 1, 2.1, addition, property of equality. So we're going to be using, it's kind of going to be a review of some algebra concepts I've already taught y'all, but it's also going to use the, some of the identity properties of the identity and inverse properties I just taught y'all in lesson 1.10. So if you need to review that, you can. Otherwise, you should be able to pick it up pretty quickly. So let's start with page 46, example 2.1a. It says determine if x equals 2 is a solution to the equation. So let's start with the equation we have. We have 5x minus 2 equals 8. What does it mean to be a solution of the equation? That just means if x equals 2, is this a true statement? So let's substitute. It says x equals 2, so let's do a substitution. 5 times 2 minus 2 equals 8. 5 times 2 is 10, minus 2 equals 8. 10 minus 2 is 8 equals 8. So is this a true statement? Does 8 equal 8? Yes. Therefore, x equals 2 is a solution to this equation. Let's take a look at another. X plus 3 equals 6. X still equals 2, so let's do a substitution. Is x equal to a solution to this equation? Let's substitute. Plus 3 equals 6. 2 plus 3 equals 5 equals 6. Does 5 equal 6? No. Therefore, x equals 2 is not a solution to this equation. That's all it means to be a solution. Now let's look at the flip side. And this is just standard algebra that I've done with y'all before. So if we have x plus, this is page 47, example 2.1b. X plus 2 equals 10. The question is solve for x. Solve for x just means get x by itself. So we want to ask, right now, what's happening to x? It's being added by 2. What's the inverse of addition by 2? Subtraction by 2. So let's subtract by 2. And what we do to one side, we also got to do to the other. So these two things cancel. What are we left with on the left? X. What are we left with on the right? 10 minus 2 is 8. So this says the solution to this original equation is x. And we can see that because if we substitute x into the original equation, we get x plus 2 is 10. 10 equals 10. Yes, that's a true statement. It's a solution if it creates a true statement is one way you can think of it. Let's take a look at another. N minus 10 equals 2. We want to solve for n. Solve means get n by itself. Right now, we ask the question, what's happening to n? I know, Tanner, you probably think it looks like an H, and my 2 looks like a Z. Well, too bad. I already told you it's n minus 10 equals Z. No, 2. It equals 2. Dang, crap it. Alright. Ha ha ha, you got me. Alright, how do we get n by itself? What's happening to n right now? It's getting subtracted by 10. What's the inverse of subtraction by 10? Addition by 10. What we do to one side, we got to do to the other. See how I'm talking these things out? This is the same type of thought process that should be going through y'all's minds and mouth when you're doing your algebra. It starts to get your brain thinking the right way. So these two things cancel. What are we left with on the left? And what are we left with on the right? 2 plus 10 is 12. Is it a solution? Yes, because if we plug 12 back in, 12 minus 10 is 2. So it checks out. Okay. I don't need to do, y'all pretty much should get the gist. We'll do them. This is page 49, example 2.1f. 2x minus 3 equals x minus 4. We have an x on each side. Well, that's not a problem. Let's go through our steps. First thing we want to do, is there anything we can simplify on both sides? Well, we got distribution over here, which is a form of multiplication. So let's distribute. 2 times x is 2x. 2 times negative 3 is negative 6 equals x minus 4. And now we want to combine like terms. So we want to get all the x terms together and all the non-x terms together. So let's move all the x's to one side. So how do we move one x to the other side? Well, we subtract that x, and what we do to one side, we got to do to the other. So we got 2x minus x, which just gives us x on this side. And then on the right, these two things cancel, just leaving us with minus 4. And now look, we got all the x's together, and this is just a normal problem we know how to work with. How do we get x by itself? Well, what's happening to x? Right now it's being subtracted by 6. What's the inverse of subtraction by 6? Addition by 6. What we do to one side, we got to do to the other. These things cancel. We're left with x on the left. -4 plus 6 gives us 2x equals 2. And if we were to substitute it back in, I'll show you this one because it's a little more complicated. Substitute 2 for all our x's. All right, let's use our order of operations. On the left, we got parentheses. So we got 2. 2 minus 3 is -1 equals 2 minus 4. 2 times -1 is -2. 2 minus 4 is -2. Is this a true statement? Yes. Therefore, our solution is x equals 2. That's about it. And then in the next lesson, 2.2, we'll look at the multiplication property of equality. Okay, bye.